Thank you everybody for coming along. This is the last of our presentations in our Keyman 14 launch event webinar series. This is on Keyman 14 lexical models or predictive text dictionaries. We've had 9 seminars this week and this is the 9th one. The seminar will be recorded and the recordings will be available at the link you can see there, which is the same link that you came into this presentation on. So as I said, this is the one on lexical models and the deep dive here, and it's going to run for about 45 minutes. We'll make sure there's some time for questions at the end of the webinar. And I will hand over to Joshua, who is our team lead for the lexical models. And Joshua, take it away.
Alrighty. So in terms of what's new as a feature for lexical model development in Keyman 14, now, these first few points are more about how they're actually used within the mobile apps. There's actually nothing you need to do additionally to support this. We've actually just across the board improved the way that our predictive text engine makes corrections. We're now much better at fixing typos wherever they may occur within a word, and we can even correct multiple typos at once in certain cases. Depends on how many other suggestions are available for the actually typed text, etc. We also have some wonderful new features. We now have support for predictive capitalization, where we can take a look at the way that a user is typing and noticing, oh, they seem to want to have a capital initial letter. Let's make sure all of our suggestions match that. And implementing support so that you can have language-specific definitions for exactly what that sort of behavior means. In English, whenever we have a proper noun or at the start of a sentence, we capitalize the first letter. But it turns out there are some languages where that's actually not necessarily the case. There are some words where you don't capitalize the prefix, or like the first one at least, you capitalize a little further in. So we've made sure to accommodate the ability for that to happen. Now the code to make it happen might be tricky, but at least there is a way forward. It's a matter of actually solving it when it comes to it. But first, improved corrections. So corrections can now occur within the middle of the word, where before they would rarely, if ever, do so. So in this first example that you might see here, we have a clearly misspelled word. Chances are the original typer was going for, well, the word misspelled, but they kind of forgot an S in there. No problem. The predictive text engine is able to recognize, oh, there's a missing S, and then we happen to match that really well. On the other hand, if that E weren't there, we'd be really close to typing misplaced. All of the characters would otherwise match. And so perhaps, just accidentally tapped the E coming off of the S during part of the typing, because that is a form of fat finger that happens. Sometimes you make an unintentional touch. The engine will still prefer to correct for more normal fat finger scenarios, like you see on the right-hand side. If you want to make the interpretation that they're going for typo or typos. You'll note that a T is right next to a Y and the R is right next to a T. So maybe the person's left thumb was just off a little bit, and so they typed RT instead of TY. So it's going to prefer to make corrections for that kind of scenario. And it will sometimes also be able to accommodate when you just didn't type the right thing at all. It's not that you missed, you just didn't type certain characters that should be there. And our fat fingering does take advantage of where you press on each key. You're going to be a lot more likely to get the picture on the right if you're pressing on the right-hand side of the R and of the T than if you were to press on the left-hand sides, because your finger's actual location would be closer in those cases. We do make use of that. As is the case from the previous versions of Keyman, corrections do consider the current layout of the active keyboard. If I were to load up a different keyboard, let's say I wanted to type in English using a AZERTY keyboard that's normally used with French. I don't know that we have any that are explicitly flagged to allow that, but suppose we did. We'd have an A where the Q is and a Z where the W is. So if I were to press that E on that French keyboard, I might get suggestions with a Z. where it would almost never happen here because W is the key that's a lot closer. And that comes for free. Whenever you're making your lexical models, you do not need to worry about that whatsoever. That is automatically handled by the engine. We take note of the state of a keyboard and do all the analysis needed to be able to make those geometric type calculations. We have had some wonderful lexical model submissions in the past. Here are 2 languages, neither of which I know, and neither of which are Latin script. And we have working predictive text for these languages. Now, because I don't know these languages, it's hard to say how common these suggestions that are being presented are. But if you pay attention to the typed text and you compare it to the suggestions, you might notice each of the suggestions here on the left is using this key on the right-hand side of the green circle below, where the key that was actually typed is the one on the left. For our second example here, the first character matches in all 3 cases. It's the second character that is different. So the first suggestion keeps that second character, and the third one changes. Well, for the other 2, we take from the neighboring key, and it looks like it still does change that third character. It's probably pretty close in a fashion, and so it's making suggestions based on stuff that is nearby, but it's making reasonable corrections, I would assume. Considering I don't know the language, I can't guarantee it for certain, but it appears that the designer of these lexical models were satisfied with how things were working previously. So until I hear otherwise, we're working well with some good non-Latin scripts, which is exciting. Now for the nice big new feature, predictive capitalization. Our suggestions will now adapt to whatever uppercase and lowercase patterns a user is typing, as long as it's a fairly conventional pattern. I say that because if you decide to randomly do a different pattern, let's say alternating between uppercase and lowercase characters frequently, that's not a standard formal writing capitalization pattern for most languages, definitely isn't for English. So we might not be able to match ones like that, but your more conventional all uppercase, all lowercase, and initial type capitalization, like with proper nouns or sentence initial in English, those will be modeled quite well. We do keep this disabled by default. It is explicitly opt-in for any lexical model. This is because there are many languages that don't actually have capitalization as an aspect of their writing system. One fun one I'm aware of is Sinchatan, which actually has a lexical model already. This language does not use different forms in different situations for each character. Most of them are actually what we would consider to be uppercase. We don't want to constantly force lowercase these just by turning on case detection or predictive capitalization. And so it does need to be opt-in. So the 3 patterns, as you may see them in definitions for handling casing, we've got labeled as lower for lowercase, upper for uppercase, and initial, which refers to a English style proper noun or sentence initial. Though you can customize that to work for your language so long as you are able to find a way to code it well. If and only if predictive capitalization is enabled, we will consider your capitalization definitions and make sure that whenever a user is typing in all lowercase, we will be able to match against that word in your word list. So even if the word as typed actually has capital letters, we'll have a form of it stored in lowercase that we can compare against. Because that's very important since most users are going to type in lowercase by default. It's the easiest one. You're not having to go to shift layers or mess around with caps lock. People tend to type lazily, so keep the common case fast is a common maxim in our discipline. Search term keying is the rough term that we use to describe that process of ensuring we can match what the true word in the word list, but in a way that a user is going to lazily type it. also for typing perhaps in French or for certain English words that use accents that we don't have on a standard US keyboard. It can be a little painful to go out of our way and type a vowel with an accent. So often a user is going to be lazy and type without that accent. Search term keying also allows us to detect that that's a pretty strong possibility too. This is why we strip diacritics. So that example of fiance with that accent is the proper formal way to type that word, but I simply cannot type that second to last character on a US keyboard unless I know very fancy OS shortcuts, which most people aren't going to know. But we can auto correct for that very easily if we have that search term keying in place. So whenever a user enters only lowercase characters, the form that we can cleanly match against, the resulting suggestion we've decided is going to use the original form as typed within the word list. So if somebody decides in their model they want to have iPhone using the official Apple style of writing it, we need to have an uppercase P. So the proper lowercase form of an iPhone for actual normal use would be as seen here, which honestly makes me wonder what the proper, it's going to be a little awkward to handle sentence initial, I suppose, because I think this is the standard case for all forms if you follow Apple's rules, but we're not that flawless with it, I guess. But typing in lowercase, we get this. If on the other hand, we were to type the English word apple all in lowercase, if a model supported it, we might have lowercase a apple for the fruit and uppercase A apple for the company. Those could be two separate things if you have those as separate entries in the word list, because those may occur with different frequencies. Taking a look at our existing English model, I can't help but notice that we actually only have an entry for the company and not the fruit. I suppose those were merged whenever the word list was originally created and the company was more likely. So that can be an important thing to consider and maybe for us to correct in that model. So by default, we will key to lowercase since that's the most easily typed, as seen here with just lowercase IPH, and it will automatically capitalize for us if it's a word that conventionally has those capitals in its standard form. There is the Apple example. So multiple entries that differ only by casing. So here we have the two different suggestions for the same letters, just referring to the different potential uses. This is built with a slightly modified version where I just inserted the lowercase version for the example. We do need to update the actual lexical model. Please note that predictive capitalization is completely unaware of a language's grammar. We don't know if you actually have proper nouns and how to detect when a proper noun is being typed. We do not have any guarantees that any given language uses sentence initial typing, partly because different languages have different end of sentence marks. So it's kind of hard to handle that completely perfectly. An aspect of that is currently on target for 15.0. With keyboards, we have a potential spec up for automatically recognize when we should start auto capitalizing, just auto caps, because we've recognized, oh, that was probably the end of a sentence. Then these will type in that character automatically, adjustments will happen, and that will seamlessly link in with the rest of our capitalization support that is in 14.0. But we don't have that there yet, and that part will require keyboard support, not lexical model support. So that'll be a little bit fun to handle when the time comes. Now, if you want there to be this automatic adjustment with capitalization, again, lexical models that want this must opt into it. A little bit before we get to that detail is the natural question of what happens if you have those two, lowercase apple and proper noun apple, but the user is typing at the start of a sentence. In that case, both versions of apple will look identical. Capital A, lowercase, rest of the word. At that point, because the suggestions are quite literally identical, we just merge the suggestion together, because why have two things that look the same? Just use one. And so that will occur. It also works quite well whenever a user types in all capital characters. Of course, worth noting, which is a possible concern, is that you can actually have correction for spelling and for case predictive capitalization act together. So here we have AP double L, which isn't an English word, but L is awfully close to P. And so if we correct that L to a P, we get apple. And well, let's go ahead and make sure that that is fully capitalized. Those are two different aspects of the engine, and they combine seamlessly. So having gotten those aspects of the mechanics of how a user will experience interacting with predictive capitalization, so you choose to support that in your model, now let's talk about what you need to do if you want to support that in your model. That's kind of an important thing and why we've got this webinar. So as mentioned before, predictive capitalization is opt-in. It's not enabled by default, but it is a pretty simple thing to enable for some languages at least. We have here language uses casing. This is a new field you can define as part of your model definition. Including that will automatically make use of our default functions for handling uppercase versus lowercase, etc. If your language perfectly follows English-like rules using Latin characters, this is probably all you have to do. Here I've got an example of how our default English model, the MT&T model, uses it. That is literally the entire source. We just added, after the sources entry on the same level, language uses casing true, and we have capitalization working with that model. Note that our default case handling method will use the default implementations that have been put in place for a while in JavaScript and thus by extension in Typescript. You've got your old string.toUppercase and string.toLowercase. So if you're familiar with JavaScript and working with those definitions, that should give you an idea of what kind of constraints you'll be working with and what you can expect. There are some languages out there that are not as well documented, and so these functions are unaware of how to work with characters in that language, in which case you might need to do extra things or implement a custom case handling method in order for us to be able to support it well. While it would be wonderful to make use of string.toLocale uppercase and the corresponding lowercase version, it turns out that for certain older Android devices, if they are not constantly kept updated or haven't been updated in a while, which is a considerable concern for some of the language groups that we support, they may not have very reliable internet access, and so that plus actually knowing to go in and update could cause issues. And so we don't want to put undue burden there. So because of these older Android devices, we wish to avoid use of the locale-based versions of the uppercase and lowercase functions, because if they are not present, that will immediately break and the predicted text would outright fail. And that would cause more of an issue than would be solved by, we feel it's worth the trade-off of making sure it works for them to maybe not have it be as easy for just the general use case, I suppose. We do have these trade-offs that we have to consider, and hopefully in a few years, we won't have to worry about that older generation of Android devices at all, and these methods will be a near guarantee at that stage, but we don't feel quite comfortable making that call yet. So please do avoid making use of those functions. So what do you do if the default implementations just don't quite handle capitalization the way your language needs? We've added support for a custom function you can add to tell our engine how to handle capitalization. We're going to examine an example based on Turkish, which has two different variants, as we would see it, of the letter I. Now, a Turkish version is going to say they are two different letters, but I don't know their pronunciation or anything, so forgive me for describing them in this manner. So there is a dotless variant, and there is a dotted variant, the one that we're most comfortable with in the lowercase. So lowercase in most Latin scripts is dotted, while the uppercase is not. But instead, with Turkish, you have a lowercase undotted I, and its uppercase is the dotless capital. So we need to remap that behavior. Also, we have the dotted lowercase I, and then a dotted capital I, which go together. So this definitely differs kind of substantially from the standard Latin script. So we need to do something special to make this work. And we need to do it without the locale-friendly methods that not all devices support, unfortunately. So to do this, we code in Typescript a function designed to be able to handle this. Now you might notice there is this, let me see if I can get this little laser pointer thing. Yes. We have here default apply casing as a parameter on the function you can define. So if Latin style casing actually works 99% of the time for your language, you can define customizations for just the cases where it doesn't work, and then leave the rest of it to the defaults, which will definitely greatly decrease the burden for some languages, like Turkish, which now, as a result, only has to worry about handling the uppercase dotless I, turning it into the lowercase dotless, and likewise for the uppercase variant. So for lower, we have it in that direction. And obviously, we do it in the opposite direction for uppercase, as seen here. Then, for the initial case, we support a little bit of recursion. You can say, hey, so the apply casing function we have defined here, just use its uppercase for that first character and use lowercase for the rest of it. And you can do that. Now, if none of these three are matched, because perhaps somebody's using what the internet might term sarcastic case these days, where you have capital, lower, lower. Since we don't directly support that, since it's kind of a bit of a meme casing pattern, at least at this stage, we just say, keep the text as the users typed it. So when it, or as it is currently given to us, which means if it's coming out of the word list, it will most likely just return the lowercase, or the, I guess, a standard form. So if a word actually does have a capital letter, the iPhone, it will use the capital P if it's coming out of the word list that way. So, as mentioned, if your language only needs those small tweaks to default behavior, you can rely on the default apply casing parameter to keep your implementation simple. You can also use recursion within the method. The slide is largely here so that those who review this later, just looking at the slides, they'll have it in text there. Now, depending on your language, you may also need to adjust how we're able to match against your text. Like in Turkish, there's that whole dotless versus dotted. Those are two separate letters. And so we need to make sure that when a user types the dotless I, that we match to the dotless capital I. But by default, our default handler is going to have that match. Well, it actually doesn't know how to handle that, where a dotted I is going to match to a capitalized dotless I, which definitely would not make sense for Turkish. So we need to do a bit of special handling there. Recognizing the role that casing plays in our expectation of how to type lazily, we've made sure that you can then have your apply casing function be accessible within your search term to key function for that search term keying aspect. This will be passed to you as a parameter because we do a little bit of work after you've specified apply casing on the compiler side to wrap all of it together in one nice bundle. So we want to actually use the finalized version, which will be passed as a parameter. So here we would have the full model source with that big function omitted because we want the slide to actually be possible to read. That's kind of an important thing here. So note the search term to key function defined here. So apply casing is given to you as the second parameter in a function. And so here we make sure to use the composed form of normalization because we don't want to decompose the dotless I, because in terms of text representation, that is a composition with a standard Latin script capital I and then a dot diacritic. But that's not the way that Turkish is going to want to see it, and we need to preserve that character. The original default version is going to strip that. That is bad for Turkish. Don't do that. Once normalized, we then split the characters out, which is what the array from here is. It splits the string into individual characters. We're applying lowercase to each and every one of those characters, and then we just slap them back together after. Not 100% that this is perfect for Turkish, but for the purpose of our example, this will be fine since this is highlighting a way to handle one particular case. And so with that, of course, we might want to see how well this works. Now give me a moment to swap screens. I'm giving most of the presentation from a Mac, but obviously we would like to do our actual lexical model coding in Developer. So if you give me a second here. Here we now have in Developer the final version of the code. Let me see if there's a convenient zoom in. Maybe I chose the wrong thing. You'll have to forgive me, I'm a little used to working in a different development environment.
There's an open issue on the font size for the lexical model source.
Well, apologies in that case. Anyway, I have put the function actually in place this time, and the rest of the code is as you saw before on the slide. So then we can go in, compile the model, compile successfully. Yes, we know there are red squiggles. We probably could stand to make that a little nicer and have that be resolved. Then we can come over to our project file, packaging, make sure to open that and compile the package. Oh, right. I kind of forgot to actually update the canonicalization on the tag, but you'll notice that's the one aspect that it is reporting to us as a problem. So if it weren't for that, we would be perfectly fine here. Well, should have thought to set that up properly. But then you come over here, use that nice new open build folder, and the KMP would be sitting right here if I had that properly handled. I might actually be able to slip in quickly here. I believe this is the one it's complaining about. Right, save. Now it's green. We like green.
We can't actually see your build folder there, Joshua. I'm not sure if it's
It's going in the back end. like you had happened in your presentation earlier. Now we have a KMP.
Still can't see
Now,
it, I'm afraid.
really? Oh, right, because I told it to screen share that one particular thing. So there you go. So we have a KMP available now. Now, in preparation for this in advance, I've made a copy of that KMP. I just built it through command line separately before this. And I would like to pull this over for a nice example here. So give me a second to swap back over. Let's see. And find where I placed that file. There it is. And so here I have our standard English model in place with our standard English keyboard. So worth note is as I type TH, we have standard this. Good old standard English capitalization, undotted capital I. Now, let me drag in the copy that was just made. We technically support a few language codes. We're going to do it for normal English, and we give it a second to refresh everything because we did just update that Lexical model. And so now this will be a little bit different because we added that Turkish casing model function. Notice that we now have a dotted capital I, this. So we are now using a Turkish capitalization scheme. That's all. That is how you go in and start supporting specialized capitalization rules as they affect your language. Now, of course, many of you have maybe taken time to get familiar with Keyman and the Keyman language for developing keyboards. And you've gotten used to at least working with word lists and dealing with the Typescript, maybe the tab separated values files. But we recognize that adding on top of that, now we've got Typescript and other things, and we're getting into much more classical like code programming. This may start getting out of your comfort zone, and we recognize that. Unfortunately, it's kind of rather necessary to make sure we have the flexibility to accommodate all sorts of different capitalization patterns. If you run into issues or are just having trouble, please feel free to contact us and or post on the community forums for assistance. We don't know your language. Without you going in and doing a lot of the work to prepare all the core material and have that knowledge of how your language works, we're not going to have a lexical model to support your language. You're the expert we need there. However, we on the Keyman team are pretty good with handling programming. So we're going to be able to recognize the rules that you're telling us on how capitalization should work, and we can translate that into code. And so we can help you work through that process to be able to get the best final product that we could want that handles capitalization properly. Now, if it turns out you are a coder and you're perfectly comfortable with Typescript, you aren't going to need help. Well, that would be wonderful to hear. If you are curious about exactly what our defaults are, I've provided a link here to the file that defines our default handling for these two functions. So you can see exactly how it works. You can copy the code, test it out for yourself and everything to get a perfect handle. That is 100% open source. Feel free to look at it, dissect it, and possibly even make suggestions. That's one of the joys of being open source. We are able to accommodate things like that. And so that should roughly handle how to go in and start supporting predictive text, predictive capitalization. Any questions?
Many. Well, I have many questions.
Okay.
We didn't hear what you just said.
Yeah, I
before
said
that.
many. You said any, I said many.
Okay,
Actually,
pick the
yeah,
biggest one.
yeah. I mean, some people are very lucky because they have a very complex language and they can learn a lot in Keyman, like programming and doing things. And for me, the Fula is so simple. It has only 4 characters that are not like in the standard uh, French English character because we use Latin. It's so simple, okay, for me. So it's a shame I don't have a more complex language so that I can learn a lot because there's a lot of things to learn in Keyman. That's it. I was just wondering what Typescript is because I don't know what it means. Yeah, that's my first short question.
Okay. On that one, so JavaScript is a language that has long existed for use with web pages and has actually seen a lot of adoption for other aspects. But one of the big criticisms of JavaScript when compared to a lot of other programming languages is that it doesn't do very much to promote type safety. Being able to track exactly what type all of your variables are to make sure that you don't accidentally reinterpret a number as text and all of a sudden you're getting a lot of weird things happening on the screen because we weren't able to tell you in advance that something went wrong because you weren't checking that you put values inside of a variable that were actually expected or that you used a function in the right way. Typescript was developed, I think, heavily by Microsoft to help address this problem. It's a language that compiles to JavaScript, but enforces a lot of typing. So while it's JavaScript at the core, it allows you to have type safety and make sure that everything actually does have expectations and that errors can be caught before you ever run the program because the compiler itself can tell you that something will go wrong. But anything that is standard JavaScript actually generally is actually valid TypeScript as well. It's just you can have the compiler help you out a lot more by adding on details about what types you're using, etc.
Thank you. So I have other questions, but maybe I should let other people ask questions and come back.
So I've got one about how to make a word list. So with this capitalization now, it's going to be difficult to figure out how to make a word list that has the right frequency counts. And I just wonder if you have any tips on that, because like in your example with Apple, now if you just put in the dictionary without frequencies, it would be easy because Apple would show up as a proper name and it would also show up as a lowercase version in the dictionary. But if you want frequency counts, I'm just not sure how to go about getting frequency counts from texts when you're going to have Apple starting a sentence and not meaning the company, and then Apple in the middle of a sentence capitalized. So do you have any ideas how you would go about getting a frequency count?
Right, that isn't the easiest question to answer right off. Ideally, you might have something with the tool that you are using to gather data that might be able to recognize, hey, this is the start of a sentence. If you had something like that, I'm not sure that you necessarily do, you might could flag those parts to review later. So you have the ones that you know are lowercase, the ones that you know are capitalized, and then the ones that are a very good question. Just filtering out all the ones that you do know does make it a lot easier to then take the time and focus on, at least I know these all do need handling. It's not just, oh, I've got to ignore 5 of them before I run into one that actually is worth looking at. Now, past that, perhaps you might could take a look and see, let's just get counts for all of the lowercase, all of the uppercase, and maybe I give up and let's just go with the capitalization just has that frequency. Or you might say, if you can do that first from before, you have numbers on how many are capitalized in the middle of a sentence versus lowercase, and we have this many that started a sentence. Well, we know what ratio happens in the middle of a sentence. It's not a bad guess to say, there's probably the same at the start. There are different approaches that you could take. Lastly, if you don't care too strongly about having absolutely perfect frequencies, there's nothing saying you can't just artificially put in a count for it and call it a day, even if that count isn't actually substantiated by anything. You can just fudge the numbers if you need to. It's not like it has to be truly the absolute right number, absolute true frequency.
Okay.
I guess one other solution would be to say that you only accept brand names that aren't also words.
I'm good. I'm good with that.
And just for our default English model, the way that it was sourced, it turns out that brand names that also happen to be words were not looked for, so they kind of snuck in. It looks like Benny has a question.
I'm right on time. My Wi-Fi just came back. So I have one question about the lexical models and frequency. The last thing I picked up, because previously the audio was like buffering a lot. But regarding frequency and the word list, is it okay if I mean, as a people or country where mixing codes are very common and talking one sentence in 2 languages or more, is it okay if I mix several languages? I mean, like Indonesian and Japanese, there are some words that might, so it's not pure Indonesian.
Right.
Or you guys looking for pure word list of a specific language, or is it okay if I, of course, not every every words in Japanese, but some maybe. So that's my question. Thank you.
Can I give an opinion on that, Josh?
Both are in Latin, by the way. Okay, thanks.
Feel free, Mark.
Yeah, so I think that there's a lot of value in having separate word lists in your source data if you can manage it. So have a source which is Javanese and a source which is Indonesian, or whichever languages they are, and then you could combine those at compile time. The advantage of going with that is that you can still have that code switching in your lexical model, so it becomes useful in everyday use. But as the model gets more sophisticated in the future, you might be able to highlight words that are in Indonesian in a different color or something like that, if you have that source data available in separate sources.
Yeah, to back up what Mark has just mentioned, I would like to point to Keyman Developer for a second. Note on the Details tab, we have word lists, plural. So here, the standard English model has a single word list, but there is an add button, and you can add extra word lists. If you do so, I mean, that'll show up here under the source as well. If you're familiar with JSON or JavaScript, the sources, again, are stored as an array. We take a list of them. These will be combined. And as had been mentioned as a feature in Developer, whenever the same word or the same text appears twice, those are merged into a single copy in the actual word list. And so those can be combined and sourced from different files. So if at one point, let's say one of those languages you mentioned has a updated word list, you can put that in place without worrying about accidentally losing the data for all of the other languages you already handled. Keeping that separate will help make it more maintainable.
Another question? Do we still have time?
Sure.
Yeah, we can keep going.
So I have a different theoretical problem. In Indonesian and many local languages in Indonesia, we are using a lot of prefixes and suffixes combination that are too much to count. So it could be, literally in the hundreds of thousands of words if we were to list all the combinations. Therefore, the ideal way is to have like something like to find the root word. What is it called? So find the root word and then possible combinations. So my question then is, should I include uncommon prefixes, suffixes in the word list, which would make it very, very long list, or should I just include common lemmas in dictionary term that we could find in a regular dictionary? Because all those uncommon prefixes are not uncommon, but like my blah 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 is not separated in two words, but in one word. Mine, yours, his or her. So those are the unnecessary lemmas that are not included in dictionary. Should they also be included as much as possible, or should they be left out? Thanks.
Right. So with a word list model, we are not able to really handle anything with adding or subtracting extra prefixes, suffixes, and the like. A word list model says, is that block of text as I see it being typed or not? That's about all it can do, which obviously doesn't work so well when you do have scenarios like the language you're talking about. For now, I would say definitely go for as much of the common cases that you can. And if there are any words that are important that might not even be so common, do still try to include them. But of course, do so up to your standard. Stay sane as you do so. If you, at some point you hit a limit, keep in mind that having something is generally better than having nothing. So just getting something out there, and you can always update it later. You can always add more. And we can update it. Oh, there's a new version out. Let me download it. Ooh, it now predicts my word. Yay. Now, in terms of something down the road in the future, we have a colleague with the National Research Council of Canada who had expressed some strong interest in adding on support for other types of models that might be better targeted to languages like yours that can handle morphology, or where you add on prefixes and suffixes, etc. He sounded like he's very familiar with that, and unfortunately, his organization ran out of time or funding, so he had to temporarily pause his work with us. Although I know at some point he does hope to be able to come back to that. Also, I wouldn't mind being able to address it myself. It's just we do have some other initiatives that are higher in priority at this time. Unicode is having a big push to get things worked out for this LDML standard that will be a common way that you can specify keyboard layouts for all languages that eventually even the major vendors will include. So by getting that ready now, we might pave the way to where Keyman for keyboards might not be necessary anymore. And we'd like to help that further along, because if a operating system automatically supports everybody's languages, that's a win. That's been the goal of Keyman, and to have that actually be fully achieved outside of this would be wonderful. So we're trying to prioritize that right now. So unfortunately, it will be a while before we are able to get to handling a better type of model for cases like with your language, but we do have plans towards that. And our design inside of the engine is such that we could drop in a different kind of model and it will work with the existing system. It's just we actually have to figure out how to properly handle that type of model and recognize its properties and do the code that would allow it to handle all the suffixes and prefixes and still be able to predict well.
Short follow-up question: how does the length of the word list correspond to performance? For example, is a short word list faster, or a longer word list make it slower? Because from my personal experience, I made an Indonesian word list a while ago, and I tried it. It like jamming my keyboard, so I had to turn it off because it make it very, very slow. Does it affect performance? Thank you.
The size of a word list will slightly affect performance. We have built into the way that it works right now, there is now a built-in timer on any predictions that are made. It will return after about a 25th of a second, give or take. At that point, it will simply give up if it doesn't find any suggestions. If it does find some, it'll just report on what it currently has found. This may cause it to miss some things that would be good, but at least it will stay responsive. Now, as a word list gets longer, it will grow, it will take more time on approximately a logarithmic scale. It's been coded in such a way, the way that a word list is compiled is in a structure that actually makes looking upwards very, very efficient. It uses a branching structure so that we only examine the parts directly related to what you're typed. And the way that the search works, it will search just as far down that as it needs to. So if a path is looking unlikely, it's just going to stop early and it won't look down there any longer. So it will maybe take a little bit longer because you will start having more branches, but it's not, but it will not get slower too quickly. So you should still be able to make a fairly sizable word list. The one other concern is that if you make it too large, it does take up memory space. And iOS in particular does care a little bit about how much memory we take up with the keyboard. And we do want to make sure not to bump up against that to where iOS would be like, oh, yeah, you're being a memory hog and we're just going to kill your keyboard. So maybe do test for that if you start making a very large word list.
All right, well, thank you, everybody. If there are any more follow-up questions, we can certainly go to the community forum and talk about, ask them there. You can get to the community forum by visiting keyman.com and clicking on the support link. And thank you very much for your attendance today. Thank you, Joshua, for presenting. We'll be putting the slides online. In fact, they should already be online now. And the video will go online probably tomorrow, Australian time, when I've finished trimming it and getting it ready. So it's been a pleasure to share this week and look forward to seeing you all in future webinars and maybe in person one day. And so I'll say bye for now.
Thank you very much,
Welcome now,
Keyman
everybody.
team.